Enzyme action. The basics of enzyme action we have known for a long time. The enzyme's active site is the lock, the substrate is the key, they are complementary and specific, the enzyme is a biological catalyst speeding up the reaction without taking part in the reaction itself. So you have the enzyme, the enzyme-substrate complex, that forms the product. The enzyme, unused and unchanged, goes back to join with another substrate, and so on and so on. At AS, the specifics become rather more important. Firstly, enzymes operate by lowering the activation energy required to start a reaction. So in this non-catalyzed reaction, this is the amount of activation energy required. In an enzyme-controlled reaction, the activation energy is going to be lowered because the enzyme provides a lower energy pathway for the reaction to occur over. Consequently, the reaction happens more quickly. Enzymes can be affected by a variety of different factors. If we start with temperature, initially, as you increase the temperature, the rate of an enzyme control reaction will increase. This is because the enzyme and the substrate will have more energy and consequently will be moving faster and be making more collisions. However, after this point here, which is the optimum temperature, so the maximum rate that you get at the highest temperature, the rate dramatically decreases because the enzyme has denatured. This occurs because the temperature is now so high that the bonds stabilizing the 3D shape of the enzyme are broken. This changes the 3D shape, which will affect the specificity of the enzyme and stop it from working. This denaturation is a permanent change. pH is essentially a measure of the concentration of hydrogen ions in solution, and changing that will cause a change in the interaction stabilizing the tertiary structure, which in turn will cause a change in shape and consequently a change in the rate of reaction. You can see that this pH here would be the optimum pH, and on either side the rate decreases. This is a temporary denaturation of the protein. If you move the enzyme from this pH back to this pH, the enzyme will continue to work. The final change comes about when you start to change the concentration of either the substrate or of the enzyme. You get the same basic graph. Initially, the rate will increase and then it will level off. At this point here, the other factor has become limiting. So if this was enzyme concentration here, then what has happened here is that the substrate concentration has become limiting, and the only way that you can increase the rate of the reaction now is by increasing the concentration of the substrate. It works exactly the same vice versa. If this was substrate concentration, then here it would be enzyme concentration that had become limiting, and it would only be through increasing the concentration of the enzyme that you could then increase the concentration of the reaction.